Hi, I am Engineer Febus Reidj Cruz from Mapua University, School of Electrical, Electronics, and Computer Engineering. I hope that you are having a great day. In this video, you will be familiar with how N-type semiconductors are made and their basic characteristics. The major types of semiconductors are intrinsic and extrinsic. The extrinsic semiconductors are either N-type or P-type. The N-type is a semiconductor added with a controlled amount of donor atoms, resulting in a greater number of free electrons than the number of holes. The extrinsic semiconductors are produced by doping, which is the process of adding a measured quantity of dopant atoms into the semiconductors. One method of doping is by diffusion, which involves placing the semiconductors in a high temperature environment, around 800 to 1200 degrees Celsius. The high temperature does not liquefy the silicon because the melting point of silicon is around 1400 degrees Celsius. However, this temperature provides energy to the valence electrons to escape and break their covalent bonds with neighboring atoms. And while in a semi-molten state, the semiconductor is exposed to dopants that diffuse into the semiconductor material. The donor dopants to make N-type semiconductors are pentavalent atoms, the elements under group 5A, such as phosphorus, arsenic, antimony, and bismuth. The common dopant for N-type is phosphorus because it has the smallest atom in the group, allowing easier entry into the material. After a time, the temperature is lowered and the material forms back into the crystal. Every phosphorus is now settled with silicon atoms, with their fifth electron as a free electron. The addition of donor dopants to intrinsic material obtains an extrinsic semiconductor with dopant atoms having complete 8 valences and with 1 free electron. Hence, the material is described as negative or N-type. Unlike the extrinsic semiconductors, where the carrier density of free electrons N is equal to the carrier density of holes P, in N-type, the carrier density of free electrons is more than the carrier density of holes. Hence, the free electrons are the majority carriers in the N-type. The carrier density of free electrons in N-type is determined by the concentration of donor atoms, N sub D. Every donor atom provides a free electron without a hole pair. While the carrier density of holes in N-type is calculated by dividing the square of intrinsic concentration and sub I by the concentration of donor atoms. In summary, N-type semiconductors are manufactured by adding pentavalent donor atoms to intrinsic semiconductors. The concentration of donor dopants determines the carrier density of free electrons in N-type semiconductors. Each donor atom provides a free electron without a hole pair, which makes the semiconductor material negative type. The majority charge carriers in N-type are free electrons, and the minority charge carriers are holes. Keep going with this series on basic physics of semiconductors. And before we end this video, please allow me to encourage you to appreciate your studies and enhance your creative and innovative ideas. Thank you, and see you again in the next videos. Thank you very much.